What's poppin', dogs? Mr. Allen here, and we're about to write a couple rational functions with particular, wonderful, fantastic features. All right, we got write a rational function with a domain restriction of x does not equal 3, a range restriction of y does not equal 0, and a y-intercept of 0, negative 4. Now, anything to do with the y, meaning my range or my y-intercept, is generally an afterthought for me once I've worked through the problem a little bit. So I'm going to start with my domain restrictions. Domain, denominator. Those guys go together like peas and carrots, as Forrest Gump once said. All right, so I'm going to have, let's say, f of x equals, and then in my denominator, I got to have x minus 3. Because if I plugged 3 in, it would cause that denominator to be 0, thus it's undefined, right? Now I got to figure out if there's some kind of number that goes up here. Now, my range, y does not equal 0, means that I have to have a smaller degree over a larger degree and no shift up or down right here. So as it sits, as long as I just throw a constant up here, 1, 2, 3, 4, whatever, then we're good to go on that range does not equal 0, okay? Because that'd be a horizontal asymptote of y equals 0. My y-intercept, that's the kicker, right? I need an output of negative 4. So let's do a little side math. If I had 0 going in, I want negative 4 out, right? So I want my fraction to be 0 minus 3, so negative 3. I want it to equal negative 4. Well, what would need to go into my numerator in order to get that to happen? Some number divided by negative 3. Well, that some number would be 12, right? 12 divided by negative 3 would give me negative 4. So if I throw 12 up in this bad boy, let's go through the check again. Domain restriction, x does not equal positive 3. Boom, right there. Range, y does not equal 0. We got it right there, right? That is a horizontal asymptote of y equals 0 for this particular rational function. And then if I plugged 0 in, I'd have 12 divided by negative 3, which gives me negative 4. This bad boy checks out. Oh, yeah. Oh, yeah. One more. Let's do it. All right, we're cruising, baby. We're cruising. We got write a rational function with vertical asymptote x equals negative 4, horizontal asymptote of y equals 1, and a y-intercept of 0, 3. Basically the same question, but worded a little bit differently, right? Domain restriction, vertical asymptote. Those guys go together, right? Range, horizontal asymptote, once again goes together, and then we got our y-intercept. So let's set it up in the same way. I'll go g of x this time, right? I want a different name for my rational function, you know? Denominator is going to have that x plus 4, so that when I plug in negative 4, it's undefined. Thus, we have our vertical asymptote. Now, the y equals 1. That one's interesting, right? I got to figure that out. Now, one way I could do that is I could have some kind of an x with some stuff up in my numerator, or I could also just shift this bad boy up 1, right? And then I got to think about some things in the same way I did over here. If I plug in 0, I'm going to have 0. Let's do a little side math again. All right, I'm going to have 0 plus 4 and then plus 1 out here. So if I want 3 to be my output, this little chunk right here, this fraction needs to equal 2, so that when I add 1, I get 3, right? So what number needs to go in my numerator there? Well, if I threw an 8 up here, 8 divided by 4 is 2. 2 plus 1 is 3. So I'm going to throw an 8 right up here. Now this guy checks out vertical asymptote at x equals negative 4. Sorry, vertical asymptote of x equals negative 4. It's an equation of a line. Horizontal asymptote, this section right here would give me y equals 0, but we shifted up 1, giving us the y equals 1. And we have a y-intercept. When I plug in 0, I get 8 divided by 4 is 2. 2 plus 1 is 3. Boom, y-intercept of 0, 3. Now you might be thinking, bro, is there another way to do this bad boy? Heck yeah, there's another way to do this bad boy. Let's throw down a little h of x. Woo! All right, so it's going to start the same way, x plus 4 right here, but I could throw an x up here. Now my degrees are the same. This has a y equals 1 horizontal asymptote as it sits. It has a vertical asymptote of x equals negative 4, but I don't have my y-intercept checked out yet. Because if I plug in 0, I'm going to get 0 over 4, which is just 0. But what if I add 12 here? Now, why 12? Well, because if I plug in 0 for x, I'm going to get 12 over 4, which is 3. Boom. This guy right here in blue also works. These two answers here check all the boxes of this particular problem. This one, just one solution really is that I'm really thinking of. But other than that, guys, that's pretty dope, man. That's a whole lot of information there, and I hope you liked it a whole lot. We didn't have any holes in this one, removable discontinuities. But hey, that's all right. Okay, stay dope.